Hello everyone, my name is Affaan and today I'm going to derive the quadratic formula. So I woke up this morning and I had this urge to derive a formula and I thought, what formula could I possibly derive? And I thought about it and I thought about deriving the quadratic formula because it's the most infamous formula in high school. At least you learn it in grade 10, I believe, at least in Canada, that's what they do. You learn it there and then that's kind of like the infamous equation that everyone remembers. It's dreaded too because, who wants to use the quadratic formula if you can factor or do anything else. But yeah, I thought about deriving it because we all know how to use it, we all have it memorized. Why not make it, It's a pretty cool thing that I thought I'd do. I'm pretty sure I've seen the derivation before, otherwise I wouldn't be trying it. But it was a long time ago and I thought, well, why not just try it out? And I'm just doing it and I haven't practiced this before, kind of like my other videos. I'm just going to go ahead and try to derive the quadratic formula. I don't know how well this is going to go. I mean, if it's up on YouTube, that means I did it properly. If it's not, then I didn't do it properly. But let's see. Well, I'm going to go ahead and try to derive this formula, see how far I can get. Alright, so I believe, from my memory, if it serves me correctly, you start off with a normal standard form equation of the quadratic type. So what I mean by that is you probably, hopefully, you write this out. You write ax squared plus bx plus c. So essentially we're just trying to find the roots of this equation. It can probably have two real roots. Yeah, that's the maximum roots it can have. Anyways, I'm getting on a tangent that I don't need to. So we're going to try and solve for x here. We're going to isolate x. So if I remember this correctly, I believe what they do, or I remember seeing the derivation, was you go and do the complete the square method. So if you remember what that is, I haven't actually made a video on it on my YouTube channel, but I should do that. Completing the square is just a way to turn a quadratic equation into vertex form, or it basically gives you the coordinates of the vertex right off the bat. So that's something you can always do with the quadratic. We don't tend to use it too much as we go up because we really are just interested in finding the roots. But when we derive the quadratic formula, for some reason we actually take the complete the square method. So what I mean by that is, just watch. I'm pretty sure if you're familiar with the complete the square method, then you already know what I'm going to do. I'm going to pull the a out, right? Only out of the first two terms. So I'm going to have x squared here, and I'm going to have b over ax plus c, right? I haven't done anything that has changed the formula. I've only pulled the a out of the first two terms. So if I brought this in again, it would be ax squared, and the a and a would cancel, and then you'd literally get the same thing again. So I haven't done anything illegal mathematically. Everything's good so far. Alright, now that we have that, now we're going to go ahead and actually complete the square. So maybe, I got new markers by the way, so if my handwriting's bad, then that's being blamed. Over up here, first time using the green. Okay, over up here we're going to complete the square, so it would be b over 2a, or, I'm getting ahead of myself. It would be b over a divided by 2 squared, because that's how you complete the square, right? You take that term and you divide by 2 and then you square it to get the extra additional term. So if I do that, I would get b over 2a squared, because dividing by 2 is the same thing as multiplying by 1/2, and then I'd get b squared over 4a squared, if I brought that square in. So what I did here should not be too surprising. Just completing the square method. Alright, now I'm going to add this term into here, and again, I'm going to add and subtract it so I don't break any mathematical laws. So if you just follow along here, so I still have x squared, I still have b over ax, and now I'm going to add this term, plus b squared over 4a squared, and then I'm going to subtract that term, b squared minus 4a squared, because I added and I subtracted, so nothing, the equality doesn't change, or nothing changes. I'm going to close that, and I'm going to have a plus c on the outside. And again, this is all equal to 0. Maybe I should bring that down. Okay, so this is what we did here. We just added the plus b squared over 4a squared, and then I subtracted the b squared over 4a squared. So that's what I was doing. Now what I'm going to do is I'm going to pull this one out. So this term right here, I'm going to pull it out by multiplying this by a, so it's going to come on the outside. So what I mean by that is a stays here, okay? x squared. You know what? I'm going to go ahead and collect this and make a perfect square trinomial. Or, yeah, a perfect square trinomial. So I'm going to actually complete the square. So this is going to turn into x plus b over 2a squared. So I collected that, and I'm pulling this out here. So this is actually going to turn into minus b squared. So multiplying, so it's just going to be 4a. And I'm going to have plus c equal to 0. This is probably the biggest step that I've done so far. Over here, this should be pretty easy to follow. This one was pretty big, so let me just go over that again, what I did. What I did was these three terms here, I factored, made a perfect square trinomial there. If they were a perfect square trinomial, that was the whole purpose of this. Anyways, I collected that, put the power of 2 there, this is fine. And for this term here, I multiplied a by this, so this would come out here. And when you multiply a by this term here, one of the a's will cancel, so I have 4a instead of 4a squared. And that's outside the brackets, and then you have plus c. Now all the hard work is really done. Now what we're going to do is we're going to isolate x. So the first thing I'm going to do is I'm going to bring these terms onto this side. So what I mean by that is on this side I'll have a x plus b over 2a squared, right? You're going to bring all this stuff on the other side. So this is going to become b squared over 4a. There's a negative here, so it becomes positive here. And the c becomes a negative. Alright, good, we're getting somewhere. It's starting to look like something. Next step is this side right here. I'm going to put over a common denominator of 4a. So I'm going to multiply c by 4a and just put it over a common denominator just to make things a little bit more cleaner, a little bit more better. I think I'm going to run out of space, so let's just keep going, see how far I get. Okay, so what I mean by that over the common denominator thing that I was talking about, so 2a squared, this will become b squared minus 4ac. Hey, look, that looks familiar, because I multiplied this by 4a, and I can actually just put this over 4a. Alright, that's all good, nothing too bad about anything so far. Now we just divide both sides by a. Let me get rid of this. We're going to divide both sides by a because I want to get rid of this a. Isolating x is my final destination. So what I'm going to have at the end is x plus b over 2a squared is equal to b squared minus 4ac over, so it was 4a, right? And if I divide by a, it's the same thing as multiplying by 1 over a. So I would just have 4a squared. Okay? So this is what we have so far. Let me erase that. Actually, maybe I can finish the proof up here. Okay, hopefully you guys can follow me up here. Okay, so we have that little bit there. Now what I'm going to do is I'm going to square root this entire thing because there's a square there, right? So isolating x is my concern. So I'm going to square root the entire thing, and I'm going to have x plus b over 2a, because I'm taking out the square. And then on here, I'll have a huge square root over here, and I'll have b squared minus 4ac over, damn it, this is a b squared over 4ac over 4a squared. Okay, so that's how it looks like so far. And one thing I did forget to mention here is this is equal to plus or minus. So whenever we take a square root, it's actually possible that you'll have two roots, like a positive and a negative, because that's how square roots work. So that's why I have a positive negative here, if you don't mind. Alright, great. So now what I'm going to do is I'm going to take the square root. I'm not going to apply it on the top, I'm going to apply it on the bottom. So watch what that means. So I'm going to have x plus b over 2a. I'm going to have plus or minus, and on the top I still have the square root, b squared minus 4ac. But on the bottom, I'm going to apply the square root. So what's the square root of 4a squared? Well, that's just 2a, right? And you'll see why I did that. So on the bottom, I'm going to have 2a, right? Because I applied the square root on the bottom, not on the top. And don't worry, that I'm not breaking any rules there. And the reason I did that is because now I can bring the negative b onto this side, or the b over 2a onto this side. So it's going to be negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. If it's a common denominator, then I can go ahead and collect the terms. So x will be equal to plus or minus, or damn it, not plus or minus there. It's going to be negative b plus or minus square root of b squared minus 4ac. Why don't you just say it along with me, because it's just so popular. 4ac over 2a. And there we go. Right there, that's your formula. That's the derivation for the quadratic formula. So if you were ever curious, or you just forgot how the quadratic formula was derived, well, here you go. And well, now it's going up on YouTube because I did it correctly, didn't make any mistakes, luckily. Yeah, if I did make any mistakes, please catch me in the comments. I don't think anything went wrong here. Alright, well that's about it. It's a quadratic formula derived. Might derive the cubic formula. I actually haven't seen that derivation, so I'm going to have to go study that before I derive that on camera. Well, I hope this video was helpful in some way if you wanted to see how the quadratic formula was derived, so you now have it. And please hit the like and subscribe button. I say that because every single other YouTuber says it. I want to be like every single other YouTuber, so I'm just going to say it. And no, it does help the channel, of course. So hopefully I'll do some more derivation videos if these get a little popular. Anyways, that's it, and I hope you have a nice day.